Welcome back to Chapter 2. We're going to start with Lesson 1 here, talking about linear growth. If a quantity starts at a size of P naught, this is P with a subscript of 0, it's called P naught, and grows by D, which is going to be our difference, every time period, then the quantity after N time periods can be determined using either relation. So the recursive form of this would be you take the previous term and you add whatever that difference is. Like say you're going up by 3 each time. I would take whatever my previous number is and add 3 to that. And I would keep repeating the process over and over again. Now, that doesn't work so well though if you don't know a starting value. This is more like maybe, you know later on in your sequence, the previous term was this, your difference is this, what's the next one? The explicit form is what a lot of people typically like better. So this is P sub n equals P sub 0 plus D times n. Now, this looks like a bunch of letters and gibberish, but if you think about what's actually going on here, this is actually just really slope-intercept form. Your good old classic y equals mx plus b. In this case, D would be the same thing as your m, your slope, it's your rate. N would be like your x, and P sub 0 would be your b, your start point. D represents the common difference. What that is that's the amount that your population is changing by, whether it's increasing, decreasing, whatever is going on. It is that amount. So an example here. The population of elk in a national forest was measured to be 12,000 in 2003 and was measured again to be 15,000 in 2007. If the population continues to grow linearly, what will the elk population be in 2014? So linearly is where you're increasing or decreasing at a constant rate each year. Now, realistically, populations are not going to usually change like this, but for the sake of this problem, we're going to assume so. Now, they didn't give us the rate, so what we got to do is figure that out first ourselves. So we're going to first figure out what our D is, which is going to be the change in population over the change in time. So how many elk are we increasing by, in this case, each year? So we know in 2007 that we had 15,000. And we're going to subtract from that 2003 when we had 12,000. 15,000 minus 12,000 is a change of 3,000 elk over a time period of 4 years. 3,000 divided by 4 ends up telling us that we changed by 750 elk each year. Now that we know our common difference, we can go and use our formula. N equals 0 will be our year 2003. P sub 0 is going to be our start point. So for the year 2003, we started with 12,000 elk. We can write an equation to represent this. So it would be P sub n equals our original, which is 12,000, plus our D, our rate, which is 750, times n, which would be the number of years since 2003. We are doing 2014 here, which is 11 years after 2003. So we're going to use our equation. We're going to replace n with 11. So this is P11 is going to equal 12,000 plus 750 times 11. 750 times 11 is 8,250. We add that to our 12,000, and we're going to have a total of 20,250 elk in 2014. All right, example. The average fee to use an out-of-network ATM was $2.66 in 2004. By 2014, this fee increased to $4.35. If the trend is linear, find what the fee will be in 2020. So first off, we have to figure out what the average rate is. How much is it changing each year? So we do 2014 minus 2004. And we're going to do our new amount, 435, minus the original of 266. What this ends up coming out to is a change of $1.69 over a 10-year period. You divide those, it comes out to 0.169 each year. Whatever year you start with in your problem is going to be your year 0. So for year 0, that's going to be the year 2004. In 2004, we had $2.66 for a price. So to write our equation, we're going to do Pn equals that 266 plus 0.169 times n. We are doing for the year 2020, which is 16 years after 2004. So that will be your n in this case. So we do P16 equals 266 plus 0.169 times 16. 0.169 times 16 is 2.704. Added to our 266 of original gives us a grand total of $5.36 in 2020. Last example here. So they give you an equation like so. They want you to use this to find P27. So all you'd have to do is just plug 27 in for n and work it out. P27 equals negative 7.1 minus 2.1 times 27. 2.1 times 27 is going to be 56.7. Negative 7.1 minus 56.7 gives you negative 63.8.